we have a MacBook Air, and it says description says it's not charging. And so if we open the device, a takeaway from the keyboard, um, from the FN key, what can we take away from that from the FN key? M1. You flipped it the other way around. Yeah, M1. So okay, so this is an M1 device. So it's coming in for no power. And also, if you're not able to pick it up from the keyboard, you can pick it up from the model number. So it's going to be 232337. Okay, so this is coming in for no charging. So I just want to do a bit of a background on when they say the device is not charging. I think we did talk about it. So we said that it has to be differentiated. So is it that it does not charge the battery or it does not power with an adapter? Do you understand? Yes. So it's two things. So when the client said to you, and it has to be clear. So it's either it does not power with your charger or it does not charge the system's battery. So when they say it's not charging, the follow-up question should be to your client, does it power on with a charger, with a connected charger? So if they say no, it does not power with a connected charger. Now, that does not necessarily mean that you have a problem with your battery because it doesn't even take in power from the charging port. Do you understand? If it takes in power from a charging port, but it doesn't charge the battery, for example, it says plugged in not charging or battery not detected, all of that information, that can also come through from the client to say that it is not charging. So you need to have a differentiation between these two to find out if it is that it powers from the charger, but it does not charge the battery, or it does not even power from the charger at all. Is that clear? So yes. Whenever you get information about it's not charging, you want them to give you further information. Is it that it's not charging? Meaning that when you connect your charger, there's no communication communication from the charger to the machine, or that it charges the machine, the machine powers on, okay, but it does not charge the battery. Okay, so this one it says MacBook not charging, so we're not sure exactly which of those two it is because this is not coming directly from the client, it's coming from the company. So we need to find out what that is. So we are say that again. Okay, check. Oh yeah, okay. So it says check Type C port not charging. Okay, so which means if that is the case, it means the device should power on. Oh no, it won't power on because it will power on if you have a charged battery. But obviously, so if they say it's not charging, so that's another thing because sometimes yes, you can get the device to power on from the charger, but it's not going to charge the battery. But yes, let's find out exactly what it is. So let's quickly take out the back cover. We could just plug power to it, but we are not going to do so just in case it's liquid. So let's first ensure that we are not dealing with a liquid damaged device. Okay, so as you guys already said that's an M1. And the fact that it's coming from another repair company, it's definitely they must have done a test, which is putting another charging port to see if the problem is the charging port. So the fact that the fact that it's here, it's definitely because that has been tested and that didn't work. So it doesn't look like it's liquid damage. Just gonna look a little closer to let's see if there's anything stand out. Okay, the machine looks very clean actually. So the first thing I'm going to do is what am I going to do? What's going to be the first thing? Yeah, I'm going to unplug the battery. So that's the first thing I'm going to do. Let's unplug the battery. So this is a single battery to board management system. It's not like the other ones where you have a main battery power line and a cable as a data line for the battery. So this one is just single. So just this, and that's it. The battery is disconnected. So now we are going to connect power to it to see what is it. And in this case, we are not really going to be interested in looking at for a short like we would regularly do on our PP bus, because the fact that they say it's no charging, it's yeah, yeah, somehow they, because if they didn't get to see the device power on, they wouldn't say it's not charging. They would use a different description. Yes, again, we might yes check for a short, but that would be which region are we going to check? If we even need to check for a short, what region is our short is our short going to be contained? The DC in, so which is basically where the charger is coming in, or you can say uh, yeah. So let's connect charger to it and see what is it that's happening. Start with the first port. We can check to see if we have voltage at all, or we can just see if we have trackpad feedback. We don't have trackpad feedback. Okay. Let's see. What do we have? We can, this capacitor is sitting on a PP bus line. So let's see, do we have voltage on our PP bus? Voltage is 0. Okay, so we are supposed to have voltage on that line. The fact that we're getting 0 volt on that line, that is very, so that it's indicative that we don't have anything coming from the charger, because even if we have 5 volt on the charger, you will still have PP bus voltage. But now that we're getting 0 volt, and I don't think it is because of a short on that line, because like I said, if you have a short on PP bus, the device will not power on. So if the device wasn't powering on, they would not say that it's not charging. So you see with this one, I'm not taking out the screws here, I'm taking out the screws from the charging port, because I want the charging port to still be on the board. So with this one, I'm using a T5 and a T4. Okay, the board is out. That looks like, I say that, I'm not sure. Looks like liquid. Okay. Let's see what's happening on the other side of the board. Okay, yeah, it's liquid. You can see that. You can see that.
Yeah.
So there was liquid in that region of the board. Okay, so two things. From the look of this, it could be that the only issue is these capacitors here, especially this one, or it could be that that guy also failed. So the first thing we're going to do is we're going to check for a short along those capacitor lines, and if we have a short in them, we will replace the capacitor and then reflow the chip. If we don't have a short in them, we are just going to go ahead and replace the chip. Okay, so this is the board view. It's a MacBook Air M1. It's going to be 820-21-600-0021 00, yeah, not 00165, 0021 600. Let's see, 21, yes, 21, 0021, 21, 21. Okay, it's been, I don't have it open. Let's see. Hmm. 2016. That one. That's the guy. Okay, so that's the board. Let's look at the area of this capacitors. So this is so this is a section here. So we are going to check this. This was the one that I was saying that it appears to be shorted. So let's see. We can use, so we can use CF260 to see if I was short on it. And that's going to be, now we can use this one here. So which is this guy, this capacitor here, sitting on the same line. And see, you see that it has a short on the line, and that is corresponding with this capacitor here, the one in the middle. You understand? Because of the way it looks, it clearly looks like a 40 cap. So that corresponds. So when I say corresponds, you see when I click there, it shows that it's connected here. It's connected to this. It's connected here. It's connected here, and then it's connected here. Here, because I might not get a pad to do my measurements, that's why I decided to look for something that is easy. That's why I used that one. So let's remove that capacitor first. So we remove it and then we do a reflow. So we're not just going to remove that one. The one next to it, even though that doesn't, even though we're not going to check for short on that one, but that also do not look good. Even if it doesn't fail now, it's going to fail in future. So we're going to remove both and then reflow the chip in the process. Can I have another board like this? Let's have a get one that has some components already taken out because that seems to be complete still. Okay, we're going to check to see if the short is gone or if we still have a short on the line. Okay, short is gone. But wait, we have in 04. Okay, is it increasing or 0442? So because also the temperature of the board also might play a role sometimes. Okay, let's give it a bit of time to cool off and then we'll check it again. You see that? Yeah, it's fine. We can use this. Some of the components on this one is yeah. Okay, let's clean that section of the board. So you see, what I'm gonna do is when I'm doing the replacement, it will be easier for me to replace to start with this one and then that one. You understand? So I'm gonna take. I'll start with the second and then the last because if I place the first one, it might be difficult for me to have room. You can use any of them. It doesn't have to be. I'm still gonna go and make sure it's straight. And this one. Okay. Give it a bit of time to cool off. Okay, let's check again to see that we have a short on that line. Okay, the capacitor that we installed is it faulty? It's very,
Before we put it, I'm not sure that it
yeah. Okay, so let's take out that cap again. It's interesting. Has the cap we installed faulty or the chip has now become shorted on that line? Let's see. Actually, looks like we made a mistake. Looks like we use this reading. We use this capacitor, not this one. Now, not before, like now. Because this capacitor, this side is ground, that is main. This is main, that's ground.
so we
It looks like we use this one now, not before,
not before.
but now we
When
looks
we
like we
made it.
use, yeah, just now we use this capacitor here, which is ground. That is main. Because there's a cap that we just took out now. Let's say, that's the cap. So if we do this, the cap itself is not faulty. You see that? So we use a different capacitor for the measurement. Basically, we use a different capacitor, even though the capacitor itself is not faulty, but because we use the ground pad of the capacitor. You understand? That's why we. Okay, so let's put that back. Okay. You understand what I'm talking about? So instead of using this one, CF2260, we use CF60712, which is the ground pad itself. You see the GND? So we use the ground pad, which is that side, and the other side of it, it's PP bus.
What do you mean exactly by the ground pad?
So you see, this is a capacitor, correct? Whenever I see the first letter being C, it's used to indicate that the component is a capacitor. Now, the component has, okay, so the component has three sides. By three sides, I would say this is 1, 2, and 3. You see, they are coded different, they are color coded.
Yes.
So this has a different color, that has a different color, and that has a different color. Where you find pp bus underscore 3vss 3s2 underscore v in, now that is the power line. Yeah, not voltage in per se, but that is, remember we say it's 1 2 3, correct? Now that is the pad that is connected to power, correct? Now this pad GND is connected to ground. Ground is always 0 volt. You understand? Now, in between them, you have insulation. So there is a material that separates one from becoming equal to two, or from one connecting to two. When this fails, when this capacitor fails, this material will no longer serve as a bridge between pin 1 and pin 2. Then whatever you have on pin 1 becomes equal to pin 2. In that case, we say we have a short to ground, which means we are saying that this line is now effectively connected to ground. No, yeah, because there is the material here that is supposed to create a barrier between this and this is no longer working as it should. Yeah. But the more we move on, you will get to understand more of what is a capacitor and how it's used, the different scenario or the different package it comes in, how you identify them, the types of capacitors, all of that. While you're doing this cleaning, the way I'm doing it now, you have to be very careful not to pull off components from the body. So you be very careful. Okay, so we did confirm that we don't have a short on that line. So now what we are going to do is we are now going to do the same thing we did before, which is to connect power to it and see what is it that we have. So these capacitors here, this one, they are sitting on the PP bus line. So if you look at it has some kind of markings on them. You see that? That marking symbol, that is a symbol to tell you that that is the side of the main. The other side without the marking is going to be ground. You understand? If you look, this is also a capacitor. It's the same thing, has a marking. This side, that's the main. This is also a capacitor. Say that's the main capacitor. That is the main. You understand? So we are going to use the main now to check to see if we have a short, if we have power on our PP bus line, which is this side. We have 0. Okay, so we still do not have, we don't have voltage in actually. Okay, so we might be having a, wait. Okay, looks like it's lifted. Actually, also that is something else I wanted to say. So when you're working on this side of the board, it is better to remove the charging port, because when you apply heat from this side, what happens is the bit of weight that this carries allows this to lift up. I'll just show you now. So the bit of weight that comes from here will cause that to lift. Yeah. So yeah. So, and I'm very sure that when we did that, so it lifted, and now we no longer have proper communication. So let's just reconnect it, the charging port, and then try again. Okay, we still have 0 point something volt. Let's check the second port. Okay, so let's see, what do we have on, let's see, what do we have on the PPDC inline? Completely zero. Okay, and this one here, completely zero. Okay, let's see. On this side, 5 volt. Let's check this side as well. On the other side, 5 volt. Okay, we might have to replace the CD3217. And then something else I just want you to take note of. You see how so when you look at sometimes the fuse, the PPDC in fuse might not be the primary reception of your 5 volt. Or so what I mean by that is the fuse itself is going to come after you get voltage. Let's see, so if I click on, let me show you this. So here, for example, see where it says ppv bus underscore usb-c o. So even though you don't have voltage, so that's going to be your primary reception directly from the charging port. You understand? And then when it goes to your USB-C, when you then goes to your CD3217 in this case, then afterwards you now, because if I click on my fuse, let's click on the fuse. So the fuse is going to be secondary in this case, not primary. So most of the time, if you have the chip itself being faulty, yes, you will have voltage in from the charging port, but there will be no voltage on your fuse. Just like as you saw now, we didn't have voltage on the fuse. So what I want to do now is before we know that there was liquid. And also another thing with CD3217s or 15 is when one of it is faulty, it can also affect the function of the other one. So, but before we replace that one, let's see if we have a short around this one. Also 05049, isn't that a bit low? Yeah, let's have another board. Yeah, that's low. 049. Because remember we had yeah, that is low. You can give us the one you brought before? No. Yeah, because we just need to make measurements.
What will be this one?
It's fine, we can use it's not this one, but we can use it. Let's see. Yeah, see that? It is low. That's not voltage. So that's resistance. So basically what we are trying to do is I'm trying to see um I'm using continuity for my measurement. Even though we don't have a beep as we had before, but yeah, the figures we're getting are quite low. Now, and we see something that the same figure it's also present here. It's same as what you have here. So let's remove that first, and then check to see if the figures will change. And the reason why, do you know why we're removing this one and not this one? No, it's because the liquid was, yeah. Say that again. Yes, yes. Okay. Now let's check to see what is it that we have. Okay. So if we check the other one, okay, that's a bit strange. What's the possibility that they both, let's see. So on that line, okay, both. Let's have something fairly new.
Exactly what.
Example. Let's use the high mode just to be sure that the multimeter is not playing with us. Approve on ground and then background. Okay. It's a bit low. 0, 1. That's low. Check this one here. So I'm gonna have to replace both CD3217s. Yeah, that's low. Okay. Let's remove it. Now to see what is it that we have. Yeah, okay. The problem was definitely the CD3217. Okay, so let's get another CD3217. We're not sure if this works. This one's. We're not sure if this one works, but we can try them. Figures seem good. But then again, we're not even sure if the CD fits because they look like they were taken from somewhere else. But nonetheless, let's see what is it that we have. Okay, 3 volts. That's good. It's not exactly what you're looking. I mean, that's not to say that the chip is working, but at least it means that we have voltage now coming as to before that we didn't have anything coming through. And then that now we have 3.3. Before we that was obviously 0 because there was a short there. And then this one as well, 3.3. Okay, now let's see what do we have on our PP bus line. So PP bus. So this one, the PP bus is a bit different with the M series. So with the Intel, PP bus should be high in terms of PP bus should be 12.6. Then it tells you that they have 20 volt on the PPDC in. But with M1, PP bus will be when PP bus is 12.33 or 12.3, it means that PP bus PPDC in is 5 volt. And when it's 12.0.1 or 12.0, then it means that PPDC in is 20 volt. It's a bit of a like like the reverse. Because with Intel, PV bus, when PV bus is 12.6, it means that you have 20 volt on your PVDC in. With M1, if you find 12, if the voltage, if the P bus voltage is high, say you're getting 12.3, then that is to tell you that you have 5 volt in the PVDC in, which is an issue.
I see.
So it should be 12.0. It should be lower, not high.
Yeah.
Okay, so let's see what is it that we have. Let's see what we have. So you see that, and it's okay. Alhamdulillah. Now that 12.0.2, that's good because it tells you that we have 20 volt on our PPDC in. If we had 12.33 fluctuation, then so if we check our PPDC in, we should have 20 volt. 5 volt, okay, okay. Let's check again. And is it stable? Okay, that's interesting because let's see, is it that's a 5 volt? Okay, let's do this. Oh, the DC jack is out. Let's check something. Mm, see what's happening. Hmm? I'm using this the right cable. It's just one screw will do. Okay, it's just the charger is working. Let's just confirm that. The charger is working. Feedback on trackpad. Yes, we have feedback on trackpad. So we have feedback on trackpad, but do we have anything on the screen? Okay, we have feedback on trackpad, but Okay, so what we're now going to do is we're going to see if the device is stuck on recovery. Uh, M1, so what port are we going to use for DFU? What port are we going to use?
What's the question?
What port are we going to use for DFU since it's an M1 device?
First one.
The first one, yeah. So remove the charger, put it on the second port, and then let's see. But I don't understand how the device will be in DFU though. Let's see, is it in? It's not. Okay, let's see this. And it's not. Let's try that again. Okay, let's try one more time. Okay, it doesn't even, it's not recognizing DFU mode. Okay, it doesn't make its way into DFU mode. So something it's even though the device it's behaving the way it should in terms of, and the device is also making its way into SO. Now that 12.3, that's because now that we have battery connected. So if we have battery disconnected, let's try again. Okay. The device is actually misbehaving. So let's do this. Let's try again. Let's be sure which charger to connect. Let's say, do we have 12.0 or 12.3? 12.0, which is to say you're supposed to, and that's 5 volt. Hmm. Okay, let's do this. Because another thing that this will do is if one of the CD3217 it's not working as it should. Anyway, we obviously replace those two without having to know if they're working or not. So let's check something else. But why would it give us? Okay, let's see what is it we have on both ports in terms of, let's see the behavior on both ports. Hmm. Might have to solder that to make it easy for us so that it doesn't fall off. Let's see what we have. 12.0 one port, and the other port. We have a difference that might give us a hint. Same thing, 12.0. It's not fluctuating. Okay, let's see. 5 volt, and stable. That fluctuate. Okay, let's see the other one. Let's see, 5 volt. Does it fluctuate? Stable. Okay, makes sense. So let's try this. Let's try it just to be sure. Let's see, is it 5 volt and stable or 5 volt fluctuates? Now it's, oh, okay, fluctuates. And the other one, let's just confirm again. 5 volt stable, 5 volt fluctuates. It's 5 volt, and it's not fluctuating. Okay, so let's replace that one. Hmm. Who is it? Hmm? Yeah, well, give us another board. It's it doesn't have to be. By the way, the CD3017 doesn't have to be from a MacBook Air. You can take from a MacBook Pro. Okay, this one reset, but we don't even know if this works. We can test it. Now I thought so. This is a guy that this has like a multiple bonds across the board. So I'm not sure if the CD3217 work, but we can look see. Let's just see if they're not shorted at least in their LDOs. That's says you cannot say OL. OL is almost as though there's nothing on that line. The OL means is open. Now we cannot use that one. So let's use that, and okay, let's use that one. But also the thing is, we even though because we not even we cannot even guarantee that that one itself it's fine. But at least we don't have a short or any funny reading across it, so we can use that one. Okay. Okay, so give it a bit of time to cool off. We have a component that has moved from its place. Let's put that back. Oh, okay. So it doesn't seem to be. Fine. OL. No, it cannot be OL. OL will mean that there's no communication on that line. Okay. Hmm. Yeah. So what we are, wait, did we use the okay. So want 04, 05, 05, 04, 05, 05. Yeah, that's fine. Okay, let's see what do we have now. Point true. No fluctuation. Do we have 5 volt? 5 volt. Okay, let's see. We getting the same thing or something different? Let's see. Is it stable on 5 volt? Stable. Okay. So okay. Let's just try something here. Okay, let's use this. Let's use the one that we took off from here. Let's use it here. Should be this one, correct? Don't forget the orientation of it. Important. Can we have let's have another one. Just like a back. Let's have something like a backup in case. Umuhalu egg ukwayetan. Okay, wa mija hiyo. Wa mija oni computer. Okay. 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 So that's formatted completely. Formatted na. Na pa formatted na lesson wa. So okay. You know. let's just have a backup just in case. Let's see, it's this 12.2. Can you see that? Like, that's what it's supposed to be. I mean, if we're getting 12.2, yeah, so yeah, around about 12.2, 12.0, that's 12 point, not 12 point, 12.0, 2. So in that case, we should be having 20 volt. So in case this don't work, we just use the ones that we are sure that are working. Let's try again. Zero. And now that's clearly 5 volt. That's clearly 5 volt. Yeah, it's clearly 5 volt. It's without a doubt a 5 volt. So this was here and it wouldn't fluctuate. Now we bring it here, it fluctuates, which will tell us that the, let's see, and the other one, still stable. Okay, let's try something. Let's yeah, let's try something here. Try the RAM chip, see what it does. Just see if it behaves the same way. This one. Let's see. Hmm. should be getting 20 volt now. We don't have 20 volt. Okay. Okay, so what we're going to do is let's use something that we confirm are both working. So we take from the other air. Okay, it's the one that we confirm works. This one correct? Okay, so let's remove, otherwise we know what's going to happen. Let's put them aside. These have a slightly different design. See if you get another one. It's just a bit. See if you get another one.
Design.
No, just see if you get another board. Not necessarily. You might not spot what I mean by the different design. You can just give me another one. Sorry. Although it's gonna work, but I just don't have any reason to doubt it. No, I don't think this has. No. Get something that looks slightly new. If not, we'll just use this one. If you don't find anything, getting 3 volt on PVDCA. Yes. Let's flip it. Let me see what is this on the other side. Let's check that one. Okay, 20 volt. So let's use something that we know are working, and if it still doesn't work, then we can be sure that we have something different happening in that section of the board. Something mount and mount. Simple solder. Mm, okay. Let's know how to route it. It's not gonna work. How to redo that one? Okay, both. We have to redo both. It's not gonna work. It's not gonna work. Okay, I'm just gonna use another. This is another pad. Empty pad. I'm just gonna using that just because I need to clean the pads. Is the cap we took out from there? Is that okay? What time is it? What time is it? 3:20. Okay, you can take a break from that. Just take a break while I clean this. Okay, so PP bus. This capacitor is on a PP bus line. I'm gonna check what is it that I measure there. Same 12.02. But now we need to be sure if it's 12.02 of same fluctuation. Is okay, let's see. Alhamdulillah. Okay, so now we have 20 volt, which is what is supposed to be in the very first place. Let's check the other one. Okay, so both 20 volt. Alhamdulillah, now we have 20 volt on both ports. So the first time we use two CD3217s that we're not sure exactly what the states were, if they're working or not. And then we took another one from which we also that. So we decided to actually confirm that yes, the CDs are working, and we replaced those here, and then as you guys can see, these are working. So the start of it all was we had a short on the LDO, which is from this camp here. We replaced that. After we replaced that, we did a reflow. That didn't work. We replaced that. We replaced the CD3217, and the behavior it gave us a behavior on the PV bus rail, which signifies is that, or which will point to you, or which will suggest that the DC in is 20 volt. But then when you check, you have 5 volt on one, which is stable, and then the other one, it's basically fluctuating, acting as though it's trying to boost. So, but then the one thing we didn't do is we did not confirm if those CD3217s that were replaced were actually working. We just assumed that they probably working. So, but apparently they know. They're not working, which is why we tried them on both sides. It didn't work. So we then had to get another board that we confirm that indeed the CD3217s are working, and then we replace those, and then we see that those are working. So, but then the next thing we're going to do is we're actually going to test it, and we are going to also replace that. But before that, let's actually see that the device powers on. Yes, we know that we get in 20 volt, but is it 20 volt powers on or 20?
With overload.
No, open line. Open line, it's not overload. It almost seems like overload, yeah? Yeah, it's open line, not overload. Yeah, it's good that you are thinking, you know.
The season doing this, I thought maybe to and equals
Oh,
to
I see what you're
you know
saying.
what I mean?
Oh, yeah, 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 yeah. Yes, it can also mean overload in that sense, because the voltage that you are putting it through, it's slightly higher than 20 volt.
Yes.
So yeah, I see what you're saying. Oh yeah, I see what you're saying. I see what you're saying. Oh, it makes sense. Oh yes, it makes complete sense. Overload. Yeah, it makes complete sense. Oh, I see. I wasn't thinking that. Yeah, it makes complete sense. Overload, and then it goes OL. Yeah, I see. Oh, okay. No, you actually no man. It makes 100% sense. I mean, because okay, so now we see that device is powers on. So what you were explaining in the very beginning, um, in terms of if it is that the battery is not charging, or and then also, can you see something which is a bit different here? The battery bar, that's a pure indication as though the battery is charging, even though battery is not connected. it's
No, it's not supposed to.
no, no, no. But remember the behavior operating systems will also play. But you look at that, you'll be like, but wait, that is a battery that, I mean, that's an icon that you get when the battery's on. But anyway, that's beside the point. Now, this was clearly not an issue of the battery not charging. It's an issue of the device itself not taking power from the charging port, and it's definitely not the charging port. So that is about it. As you guys can see, we have a working device. So the next thing we're going to do is we are going to clean the board, replace. Yeah, we have to also replace that, and yeah, that's about it. Thank you guys. I will see you guys in the next one.